from where we're all sitting in our houses all around the world. I see so many faces here and some familiar faces. Hopefully what I'm going to be talking about today will be able to give some of you a first introduction to the topic. Some of you are well versed in this topic. I see some very experienced sea hands in the audience here today. George Branch, not mentioning any names, but so lovely to have everyone sitting here today. And I'm just going to share my screen with you all. Oh, Ruth, you just got to open up screen sharing for me. But I love the fact that Ruth sort of started this session by mentioning the need for respect and kindness. And it sounds like such a silly thing to sort of start what is a marine biology session, and more specifically a conservation focused session this week with that in mind. And I was really thinking about it a bit today before I sat down to chat to you all. The fact that we're in quite a fragile moment in time across the planet. And so when I talk about what the threats to sharks and rays are, I always like to think about a favorite quote of mine from an author called Henry Beston. He was a writer at the turn of the previous century, and he wrote a book called Outermost House. And he spoke about how it is that we think about other animals and how we live with them on this planet. And he said, you have to think about animals not as brethren, nor as kindred spirits, but rather as other nations caught with ourselves in the net of life and time. And you'll see that as I begin to chat about this topic, it's really complex. Ecologists don't like a simple solution to anything. Everything is really complicated. There's no straight answer to anything. Everything is interconnected. And so I think I'm going to frame today's chat really around how we as individuals can see ourselves positioned around making a real change to what these threats are to sharks and rays. It's very easy oftentimes to get introduced to this topic, to start thinking about what it is that scientists need to be doing, what government needs to be doing, what other policymakers or conservationists need to be doing. And we definitely need to be holding everyone accountable. But I think it's more empowering to think about how we fit into this picture. And I hope this little session today will start sparking some of those conversations. I'd love to see those come through on the chat as well. And it's certainly some of the Q&A that we can address at the end here. But for those of you who've been following along for the last couple of weeks, you will know how many species of sharks we find in our global oceans at the moment. I don't know if anyone wants to pop that answer into the chat. I can't see the chat at the moment, but it will be interesting to see if anyone can guess how many species of sharks we know from our seas. And if anyone's putting 500 thereabouts in there, you would be correct. If we're looking at the chondrichthyans, so that's the big family, big group of sharks, rays, skates, and chimeras. So those are all the fishes that have skeletons comprised of cartilage, so the stuff that's in our ears and in our noses. The chondrichthyans, we're looking at over 1,200 species across our planet. And what's important about this is everything we've been talking about in the previous webinars has led up to this point where we know that there are sharks everywhere in our oceans. We find them in all different ecosystems and habitats, in shallow waters, in deep waters. They come in different shapes and sizes. And from an ecological perspective, this means that they have high functional diversity. What do I mean by functional diversity? It means that they do lots of different jobs in our oceans. And each of those jobs plays a role in how our oceans continue to provide us with the services that we need from it. So we call that in biology ecosystem services. The oxygen that we breathe, the food that we eat, the jobs that we have, the recreation that we all enjoy, all of that comes from the ocean. And the more diversity we have in the oceans, the better that is able to function. So having lots of different kinds of sharks and rays means that our oceans can always function better. In South Africa, you might remember from Summer's talk last week that we have a lot to be proud of. We have 204 species that can be found in the Southern African region. What that means from a conservation perspective is that we have a huge responsibility here too, because 69 of those species are what we call endemic. So that means they're found here in South Africa and nowhere else in the world. And so if they disappear from here, we only have really ourselves to look to for the people, as the people who are going to be responsible for that incredible diversity. Now, it's phenomenal to look at the range of life that we have in our seas, but why are we worried about sharks? And the real concern is that a lot of scientists over recent years have put numbers that are kind of scary to think about. There's an estimate by a scientist called Boris Worm and his colleague Myers from Dalhousie University, who put it to the scientific community that about 90% of our top predators in the oceans, big predatory fish, so that includes the rays and the skates and the and mostly the sharks, have populations that have crashed. So we have some reasons to be concerned. And for those of you who keep up to date with the news and have been seeing more and more reporting on climate change in the media, it's becoming a more frequent thing. It was something that we never heard about, and now we hear about it a lot. You'll have heard of something called the IPCC. That's the Intergovernmental Panel on Climate Change. That's the collection of the world's climate scientists, and they come together to put together these reports that give us an insight into what is happening to our changing climate. Well, the biologists of the world did the same thing late last year, and they came together as the IPPS, which is sort of the biodiversity, biological side of what the IPCC represents. And they put together this report that gives us a status update on how biodiversity, the sum of all this life on our planet, and ecosystem services, the kind of jobs that they do in helping our planet function, are faring. And the IPPS report, for those of you who read it, you will know it didn't say much that we didn't already suspect. And it's a scary document to look at. It doesn't make you feel really good about things at all. If you look at that horrendously colorful graph that I've put up there, you'll see that the red and the orange and the yellow represents where we're really worried that species or species groups are approaching extinction. We may face losing them forever. And I've highlighted there the sharks and the rays, because the IPPS report told us that about 33% of our sharks and rays in our oceans are facing the threat of extinction. And so it's my job today to chat a little bit about why that might be and how it is that we might solve and prevent some of that from happening. Now, before we get into that, I don't know if anyone has looked into how we track extinction. How do we keep a handle on which species are critically endangered and which species are recovering? Well, part of what scientists do is monitoring and reporting on tracking populations of fish, sharks, rays, skates, wherever we can get information, and putting that together into assessments. And those assessments often go into something called the red list assessment process. And if you ever go onto the website for the IUCN, it's the International Union for the Conservation of Nature, they have a red list of threatened species. And essentially that acts as a barometer of life. It gives you some indication of where on the spectrum species are. So something like a white shark there, you'll see, is listed as vulnerable. And it allows us to track, is its status changing? Is it getting worse? Is it more endangered, reaching critically endangered? Have we lost it entirely? Is it extinct? Is it data deficient? Do we not know enough about it to be able to report on it at all? Or is it of least concern? How do we manage what is going on in our oceans? So if you're interested in understanding and looking at which species are endangered, critically endangered, the IUCN Red List acts as that sort of traffic light indicator of where we are. It's the go-to flag red flag, if you will, for conservationists around the world. And the latest reports from the IUCN Red List show that actually some of the most threatened sharks in our seas are not sharks at all, but their cousins, the rays. It's a group that we call the shark-like rays, and that includes some of the sawfishes, the wedge fishes, and the giant guitar fishes. Now, I don't have photographs of all of those on the screen in front of you, but some of those species you'll see over there. And they're these flattened fishes. So you will have met the rays in the webinar by Michelle Carpenter a couple of weeks ago. And their cousins in that big group, the chondrichthyans, are also made of cartilage. They're flattened fishes that often cruise along the sea floor. But the shark-like rays have these big dorsal fins that sit high up on their bodies. And it's those fins that make them highly prized in the international fin trade. And these are actually some of the most at-risk sharks and shark cousins in our seas. Now, what is it that makes us concerned about sharks and rays? What are some of those threats that we're talking about? And there are a few that we can distill this down to in the time that we have. And I'm going to be chatting through overfishing, so our overuse of biodiversity in the oceans, pollution, the loss of essential habitats, the impact of climate change, and the impact of our mindset about sharks and what that does to shape the way that we want to manage and protect them. So if we look at overfishing, on the left-hand side there is a screenshot from the IUCN's Red List assessment page. And there it repeats what the IPPS said. It says around 30% of sharks and rays in our oceans are really at risk of extinction. They are threatened with extinction. If we're looking at just the impact of fishing on sharks and rays, this paper by a huge number of scientists was published that says we can actually look at about a quarter of sharks and rays that are threatened directly by overfishing. Now that can be legal fishing, illegal, unregulated or unreported fishing, but essentially our use of taking sharks and rays out of the oceans is what is threatening at least a staggering quarter of all the sharks and rays that we find in our oceans. Now, this is really interesting. If you've ever studied fisheries, you'll know that the way we interact with our oceans changed profoundly after World War II. We had this real increase in technological advancement. We'd had the 2 world wars that saw a huge development in radar and sonar, in the ability for ships to now go out further than they ever have before. They were able to put refrigerators and freezers on board, so it means that you could stay out at sea for longer. No one was having to row their boats out just a little way and return with their catch at the end of the day and bring it home or sell it immediately. You could stay out for long periods of time. The first time we could actively hunt fish where we couldn't see them before, because suddenly we could track them with sonar. So no fish really was left out of this footprint of this increasing industrial coverage of fishing across our seas. And if you look at some of the latest reports, they estimate that about 55% of our global oceans are covered by this industrial fishing effort. Now, the thing about sharks and rays is, unlike some fish that are able to withstand some level of fishing pressure, the way sharks and rays live their lives, they live long, they grow really slowly, they get very old, they reproduce really slowly. That's seen them do very well over the course of 450 million years. They've been on this planet for such a long time, and yet when you have that level of pressure on the oceans, those same life history characteristics are what make them the most vulnerable to a lot of fishing pressure in our sea. So if we're looking at overfishing, there are different ways of unpacking this. And inevitably, many of you are sitting here in South Africa, where I am, and you're wondering, well, do we fish for sharks in South Africa? And the answer is yes. Many of our shark fisheries are managed. About 100 species out of the 204 species of sharks and rays that we find in South Africa's waters are caught in fisheries in some way or another. And I'm not going to go too much in depth into that, but some fisheries are targeted. So we have some level of being able to go out and actively look for a specific species. So an example of this in South Africa would be something like the common smooth-hound shark. It is an active target species of something like the traditional handline fishery. So that's people going out with a rod and reel on their boats, or the demersal longline fishery. And I've put up a little graphic there because often I think it's really hard to imagine what does the gear from a fishery actually look like when we're talking about it. Now, demersal just essentially means close to the sea floor. So in marine biology terms, we talk about pelagic and demersal. Pelagic being in the mid-water or nearer to the ocean's surface. Demersal on the bottom. And demersal long lines are these long lines that are laid out with baited hooks. They can be up to 10 kilometers in length. They are interspersed at intervals, and they're baited, and they, in this case, are targeting smooth-hound sharks. Obviously, there is some level of incidental or bycatch, and we'll get into bycatch next, but there's very little impact on the seafloor itself. So there's different ways of targeting certain species, and you need to know quite a bit about the biology of a species, where it's found, what its status is, and it's that information that fisheries managers use to try and manage what is the allocation, how many of these can you catch, what is the total tonnage that you can bring back without crashing a population of sharks. But by far the majority of shark catches are incidental, or what we call bycatch. So about 2/3 of South Africa's shark fisheries take is as bycatch. And this is true also of the rest of the world. Like a major impact of fisheries is in the form of bycatch. So that's because gear, fishing gear, can be quite unselective. So one of the ones that we often use as an example of this is trawling. Trawling is, if there's not been any adjustments made to it, one of the most indiscriminate ways of fishing. So there's a trawl net, a demersal or bottom trawl net, being dragged along the sea floor, and it'll scoop up anything that lies in the path of that net. And that not only includes the animals that are in the path of that net, but the sea floor as well. So if you're dragging a trawl net over a ground of coral, you'll drag up that coral too. So trawling has impacts, you'll see now, directly on the numbers of sharks and rays and skates that it's scooping up. But later you'll also see it has implications for the habitat of where sharks and rays and skates are living. So an example here, that's a St. Joseph shark. It's a chimera. It actually is also a distant relative of sharks in the big chondrichthyine group. It's called a holocephalin. And St. Joseph sharks are bycatch in some of the inshore trawl fisheries here in South Africa. Now, this is a tricky one to unpack in a quick amount of time, but I always come back to what is it that you can do? How should you be thinking about sharks and shark fisheries? And the one answer that we always give is think about what your seafood consumption is. Think about what fish you're eating. One, because sharks eat other fish. So we need to make sure that there are sustainable fish stocks in our oceans, because that's the prey base of a lot of sharks, but also because the fisheries that catch different fish species can catch sharks and rays too. But it's very difficult, and what I haven't put here is it's very difficult to trace what seafood you're eating. So behind all of this discussion is the idea that it's very difficult to actually know what species you're eating unless you've seen it and you can identify it. So often what we see is very difficult to trace. So traceability is often an issue with seafood. So I've put there reduce your consumption if you are eating seafood at all. And then if you are, and if you reduce your consumption, then know your seafood. So the picture that I've put up there, South Africans will know it, I hope, really well. That's the sassy little pocket booklet, the little traffic light system that gives you an idea of how to look for sustainable seafood. It's run by WWF, and green is where you should be ordering your fish choices from. Orange you should be hesitating about, and red is no-go zone. And the reason is because some sharks are caught in fisheries, other sharks are impacted by fisheries. So something like, these are the sharks that are currently on SASSI's little pocket booklet list, something like a short-fin mako shark. Short-fin mako sharks, some of the fastest sharks in our oceans. They live out in the open oceans, but they come inshore as well. And they are bycatch, or incidental catch, of the pelagic longline fishery. And their numbers have been crashing elsewhere in the world. There's been huge declines in short-fin mako sharks. So something like that needs to be on a list, a barometer, so we know how it's doing, and you can make an informed decision about what seafood you're buying and whether the fishery that you're buying your hake or kingklip or whatever it is impacting other sharks and rays as well. We also need to know what's going on because some sharks have been prohibited from fishing at all. So something like a white shark over there, no one can catch it, whether you're a commercial fisher or a recreational fisher, so someone fishing for sport or for pleasure, no one should be fishing for white sharks at all. So looking at the label of your seafood is an important and influential way to use the power of your plate to make change in that sector. The other part of overuse is the illegal side of it. And I think this is the one that comes up so often with sharks because we know and we hear so much about the shark fin trade. And that is one part of the illegal trade. Sharks are fished not only for their fins, but as we've seen, for their meat and for a host of other products, for their liver oil, which as you'll see kind of makes its way into the oddest products and things that you can buy. And it's about being able to read labels and really start thinking about what it is that's going into everything and whether that could have been a shark or a ray or a skate. So at the beginning of this chat, I mentioned the wedge fishers and the giant guitar fishers. They are the most sought after for the fin trade. In South Africa, as in many countries around the world, finning, shark finning, the unsustainable practice of removing the fin of a shark while at sea and dumping the body of the shark back, or even using it, but usually dumping it back and just retaining the fin for a lucrative trade is illegal. So in South Africa, fisheries have to bring the whole shark back to what we call the landing area, which is the harbor or the port, wherever they're bringing sharks back to. Another way of trading illegally is around manta gill rakers and sawfish. Sawfish have that really big rostra, what we call that big blade, serrated blade that you'll see a little bit later on. Those are also traded illegally. Now, it's hard to put yourself into managing illegal trade. And there are international agreements that deal with illegal trade. One of them is CITES, so that's the Convention for the International Trade on Endangered Species. And CITES is an agreement between countries and governments that run countries around the world that where a species is threatened to the point of extinction because it is traded and it is over-traded and overused, it needs to be heavily managed. And there's three categories that a species can be listed on in a CITES, what's called an appendix. So Appendix 1 is the most heavily regulated, and all the sawfishes are listed on CITES Appendix 1, which basically means there is no international trade of sawfish unless there are exceptional circumstances. CITES Appendix 2 manages the trade, and about 38 species of sharks and rays have now made it onto CITES listings 1 or 2, and that basically helps regulate how sharks are exported and how they're imported, and that has implications for how they're managed through customs. Now, there's a great partner of the shark project that is run by WILDOCEANS called Traffic. They're a local NGO, and they deal a huge amount with illegal trade. So if you want to know more about illegal trade in wildlife and how that's regulated, particularly around sharks and rays and other seafood and sea life, check out Traffic's website. But if you want to know what to do about illegal trade, whether this is legal or illegal, sometimes understanding the source and its sustainability is very difficult. So my take home would be very, very cautious and conscious about buying shark products. So whether that's their meat or, you know, it doesn't have to be meat or fins or liver oil. It can be curios, their jaws and teeth, leather products. I had no idea that manta skin is really prized for its ornamental value, but that skates and rays often make really high quality leather belts and wallets. And then looking at the kind of supplements and vitamins and beauty products to look at whether shark products are part of that, the ingredients often called squalene, and they are vegan alternatives to that. So having a look into what is listed on all the things that we just kind of take for granted and buy on a daily basis. You can report illegal activity, and I'd encourage you to check out the Shark Attack campaign website at the end of this. There's some really handy numbers and links on there if you do see something that makes you concerned. And there's even a portion there that's really interesting to me about supporting a drive to donate to buy DNA testing kits, so rapid testing kits that would become usable for customs officials at border posts, because it's really difficult to know what species is being traded or being crossed across borders once a product is reduced to something like a jaw there or a fin. Fins are really difficult to distinguish to species level if they're dried. And a DNA testing kit allows customs officials to identify it right down to species level. So there's interesting innovations and ways that this is being changed as our technology improves. But this is something I think that all of us can take control of, and I think it's something that is starting to shift. And it's something that I've seen come up in how we chat about the oceans, and that is pollution, particularly in the form of plastic pollution. And it's something that we don't really think about when it comes to sharks and rays. I've put up just papers here for those of you who are going to look up the science of this afterwards. But we think about turtles when we think about single-use plastic. It's always the image of a plastic bag floating in the ocean that something might confuse for its prey, or straws. And those are all absolutely valid, but sharks and rays are affected by pollution too. On the left-hand side was a study done by some scientists in Mozambique that looked at the filter feeding sharks like manta rays and basking sharks and whale sharks. So they move through the oceans with these big filter feeding mechanisms like sieves that sift out tiny plankton from the ocean. And as they're sifting through something as microscopic as plankton, they're starting to pick up tiny microplastics, so those fragments of broken down plastic that end up in our oceans. Filter feeding sharks and rays are starting to pick those up as part of their food. Thinking about the kind of products that you use at home, the kind of products that we let run into rivers and basically out into our oceans, heavy metals, toxins, those accumulate really rapidly as you move up the food chain. So some example there is the smoothhound shark, the thing that we were talking about a little bit earlier, that's caught in the fisheries here in South Africa. Smoothhound sharks were tested in Langebaan Lagoon and found to show really high levels of mercury. And the thing about predators is they eat other species in the environment. So as something like a heavy metal, heavy metals don't degrade as they move up the food chain. In fact, it amplifies, and so the concentration is higher in sharks and rays than it is in other species lower down on the food chain. And here I'm going to put it out to you, really, in this kind of online community, to put it into the chat box what it is that you're thinking about when it comes to pollution and the ways that we can change what is going through our systems, our rivers, and into the ocean. I really like the idea of refuse, repair, reduce, reuse, recycle, really thinking about the chain of, do I need it? Can I repair it first before I buy something new? Could I just reduce the consumption of it? Could I reuse it? And as a last resort, could I recycle it? So that's sort of how I am trying to think about what is ending up in the ocean. And you can see there that big manta ray moving through the ocean. You see why it's so susceptible to picking up things like microplastics. And I think that's an awesome thing. I'd love to see what all of your innovations and the ways that you're taking this on in your lives coming through in the comments box there. and also what you're doing about beach cleanups and building community around not only beach cleanups, but river cleanups. It's that source to sea idea of whatever we're using in our houses, in the sinks and bathrooms that we're cleaning with, ends up in rivers and ends up in the ocean. One of the last things I'm going to talk about is habitat loss. And it's hard to think about because we often hear about this on land, but anything that really changes the home of a shark or a ray to the extent where it can no longer live there is habitat loss. And this can be direct, something like, you can see the Cozy Bay estuary over on the left-hand side there. Estuaries in our country and around the world are dredged and dammed, or on the right-hand side there, you can see a mangrove in the Bahamas. Mangroves are often cleared for agriculture or for aquaculture, for different kinds of farming. That is direct habitat loss or change, coastal development, buildings on our coastline, and indirect ways, leaching of pollution into the environment so that it changes the ocean chemistry, so that an area becomes completely uninhabitable for a shark or a ray. And it's the sharks and rays that live closest to our coastline that are most affected by this. I mean, habitat loss happens throughout our oceans, whether it's deep sea mining, if it's trawling or dredging, it happens everywhere. But it's particularly the big sharks and rays that use our coastline that come into closest contact with us. And it's our changing shorelines and coastal seas where we see so much habitat loss. And one of the examples I've put here to make it a little bit more real for you is the example of the sawfish. So sawfishes are fascinating to me because, like bull sharks, they're unusual in that they can use marine saltwater environments and freshwater environments. So large tooth sawfishes, that really critically endangered group species, often move up into rivers, and the young of sawfishes can be born in estuaries or reared in nurseries like mangroves. They rely on these coastal areas as nursery grounds. Like many sharks and rays, they use coastal areas and estuaries and mangroves to breed and aggregate and feed. So they're most vulnerable in these places that are changing and that we're losing all the time. And the sawfish, unfortunately, represents South Africa's first real example of what we think is a local extinction. So sawfishes are still found in a few places in the world. Florida in the United States and Australia are two sort of lifeboats for sawfishes, but they have disappeared almost across their range. And South Africa used to have sawfishes, but they seem to be gone. And if anyone works on land or in rivers, you'll know that our estuaries are also some of the most threatened ecosystems in South Africa. And it's not only habitat loss that caused the demise of sawfishes, but it's certainly one of the big contributors. So what I'm going to show you next is an example of why we need these nursery areas. It's a little video. It's going to bump and jolt, but I still think despite internet connections and our distance, it's worth watching this because it is fascinating. It was a video that was shared with me from Dr. Dean Grubbs, who is a shark scientist in the US, and him and Jake Jerome, a colleague up in the US, filmed the first birth of little sawfish pups in the wild up in the Bahamas. So they found a new nursery area and they found that sawfishes are pupping up there. If you look at the bottom of the screen there, you'll see the sawfishes have these we call rostra, with these serrated teeth along it. And as you watch this, you'll kind of think about what it's like for, I always think of like a mother porcupine having baby porcupines, giving birth to baby porcupines. How does a female sawfish give birth to baby sawfishes, sawfish, when they have that little rostra? So bear with me if this will play. Let's just see. But it's so worth watching. This huge sawfish female. So this was a small tooth sawfish species in the Bahamas. And there they were going to tag her to be able to track her. And as they turned her over, so they go into a sort of meditative state, there the little sawfish pups were born. They tagged them and tracked them and they let them swim off back into the sea. But that's, you can see what a tiny little sawfish looks like when it's being born. And I know that it's probably skipping a little bit on your side because of the internet, but still there's a tiny sawfish heading off out of into its nursery grounds, where they will spend the first couple of years of their life growing big enough to avoid predators. And that's why identifying shark nursery grounds is hugely important. So with that in mind, what can you do about habitat loss? And here I'm just going to put up this incredible link to what South Africa's Marine Protected Area Network looks like. Just like we have parks on land, the Kruger, the Kalahari, Yellowstone, wherever it is that you're from, so we need spaces at sea that give fishes, particularly sharks and rays, a space to recover and to protect essential habitats like shark nurseries and shark feeding grounds, but also to allow them to be let off the hook, if you'll excuse that terrible pun, for a little while. And so I would say that supporting marine protected areas, both the proclamation of them, but also once they're in place, respecting the enforcement of them, and then spending your money, putting it where it makes a big difference, going to travel to those places that make them worthwhile to stay wild and protected, instead of being turned over to some other kind of use. And that links to sustainable tourism. If you're going to dive in marine protected areas, if you're going to spend your hard-earned money diving with sharks, choose really reputable shark tour operators so that you can make sure that sharks are worth more alive than they are dead, and that we keep these places protected. So final 2 points before we open up to some questions if we have a little bit of time. The big one that hangs in the background of all of this, the one that is really hard for all of us to kind of get our heads around and know how it's going to play out: climate change. So how does climate change affect sharks and rays? Well, the answer is we're still figuring it out, and we'll continue to do so. But we know that greenhouse gases like carbon dioxide and methane are profoundly changing the way our ocean's chemistry works, the way the temperatures rise and fall. And what we have seen is that on land, a changing climate is moving species. They're moving away from where they're typically found into new areas. And I found this really interesting to see that Australian scientists had tracked the movement of 2 shark species, shortfin mako and blue sharks, that are moving polewards. They're moving closer away from the equator and down towards the poles as ocean temperatures change. So we're expecting changes in sea temperatures. And so as fish and the prey of sharks move around, so we expect the predators to track and follow their prey too. But I think the best example I can give currently of how sharks interact with climate change is around corals. Coral reefs are one of the most critically important discussion points when it comes to climate change at the moment. So rising sea temperatures are increasing the severity and the frequency of coral bleaching. So what happens is corals are colonial little animals. In their tissues are symbiotic little algae, so little plant cells that photosynthesize. They convert light energy into food, and that feeds and nourishes the corals as they grow. It also gives them their colors. But when temperatures rise, the corals get really stressed. And when they're stressed like that, they reject the zooxanthellae, or these little algae cells that live in their tissues. They reject them and they expel them. And when they expel them, they turn white, they bleach like this. So you can see they're a bleached coral reef. And bleached coral reefs can recover, but if they're left too long, if things don't acclimate or return to normal, those corals will die. They'll starve and die eventually. Now, there are lots of sharks that live on coral reefs and that rely on coral reefs. So if we lose corals, so we lose sharks. But it's a little bit more complicated than that, because if we keep sharks and rays, we may also keep corals. And the reason I mention this is because we've seen in the last couple of years the biggest worldwide event of coral bleaching in our history. So over the period from 2016 to 2018, corals around the world bleached in a mass bleaching episode. Sea temperatures rose. Coral bleaching happened worst on places like the Great Barrier Reef. But in some areas, some reefs weren't as badly affected, and it looks like they may recover a little bit better than other areas. And one of the reasons they think is because healthy fish communities on those reefs were able to keep the reefs kind of stable and healthy, and prevented a lot of algal growth and a shift to a different kind of ecosystem, while those corals are just being able to recover from all the stress of the rising temperatures. Those healthy fish communities could graze and keep that whole balance going. And healthy fish communities need healthy sharks. So by keeping sharks and rays around, we may yet keep coral reefs around. And so it's complex, but I think that gives us some symbol of hope that by affecting change in one area, we might be able to save other species. So the final one is how we think about sharks. And this is perception or misperception. And I find this an interesting one to end off with, because I think this is the one that I've seen changing most in the course of my lifetime. Many of you will have watched Jaws, and so you'll know that that sparked this phenomenon where we think of sharks with the idea of, fear and in the worst cases, loathing. And it really manages how we've interacted with sharks in our seas, and whether we've cared about them in the same way that we do other species. So I hope that there's a generation starting to come through that hasn't seen Jaws, or if they have, they kind of give it a laugh and are not worrying about it like the rest of us who feared up creepy crawlies in our pools after watching something like Jaws. But if you're interested in how our perceptions of sharks shape how we make policies around them, there's a really good book called Flaws, published by Christopher Neff from the University of Sydney. But it's about being a positive shark advocate. So hopefully all of you walking away from this today and from the past few webinars will know that there's a lot more to sharks than the misperceptions we've had about them, and that we can live with and manage our interactions with sharks in really clever ways. And I'd encourage you to go and look up the Shark Spotters program. If you're not from South Africa and you don't know it, that's a fantastic non-lethal way of being able to live with sharks in our seas. So what does an ocean look like without sharks and rays? Well, it's difficult to say. Often we say sharks keep our oceans in balance. Without them, we'll affect all the different species down the food web. But this is a fantastic example of how differently and how complex we have to think about sharks and rays. So manta rays in the Seychelles may be the pollinators of the coral reefs there. So there's a paper published by a woman called Lauren Peel from the University of Western Australia, and she looked at reef manta rays in the Seychelles who eat plankton, as I said, and they move offshore into deeper ocean waters to go and sieve up that plankton. And in the day, they come back to the shallow waters of the coral reefs around the Seychelles Islands. And it's while they're at cleaning stations and being cleaned and interacting with other manta rays that it's their feces that act like fertilizers on the coral reefs really close to those Seychelles Islands. And so it's incredible to think of rays like the pollinators of the seas, in this case, the butterflies or the bees. And we make such a big fuss about losing bees on land, but what would the ocean look like if we didn't have something like manta rays? So I think it's in our hands. I would love to see your comments and questions that came out of this about how it is that we place ourselves in the center of this discussion around changing the narrative for sharks and rays, stopping this trajectory of them heading towards critically endangered and towards extinction. If we can shift that needle of, as I say, over a quarter of our sharks and rays heading towards extinction, that would be a phenomenal thing, I think, to see within all of our lifetimes. And as you've seen, I think it's good for sharks and rays, but it's really essential for all of us. So I'm going to leave it there. I think Ruth's going to let